So the strategy we're going to talk about today is the quadratic formula. This is a very handy strategy because it works all the time. Sometimes you're going to come across quadratic equations that cannot be factored, or you'll come across quadratic equations where completing the square is a pain in the tail. So we are going to learn this because while it can be clunky and a little bit irritating, it is also a method that works in any situation. So let's review the two things that we have known how to do already. We know how to solve by factoring. We can look at something like this first problem, x squared minus 6x plus 8, and we can say, okay, I can factor this. There are two numbers that multiply to 8 and add to negative 6, so I can break this into two pieces, x minus 2 and x minus 4. And once I have these two pieces, I can apply the zero product property, and I can say that x has to be 2 and x has to be 4. These are the two solutions to my equation, and keep in mind that they are the two zeros of this quadratic function. So I have a 0 here at 2 and a 0 here at 4, and then I could go ahead and graph it somehow from there. We could find the vertex and do all of that. Okay? This one, there are no two numbers that multiply to negative 1 and add to negative 6. That's not possible. So instead, I'm going to solve this by completing the square. I'm going to add 1 to both sides, and I get x squared minus 6x on this side. And I say, well, what number can I add to this to complete the square? So I take half of 6 and square it, and I add 9. If I add 9 on one side, I have to add 9 on the other side. So I'm going to say plus 9 over here. It's kind of a silly way to write it, but that's fine. So we're going to now say on the left side I have 10, and on the right side I have a perfect square trinomial. I can factor that. So I'm going to factor this into x minus 3 squared. Once I have this, I can square root both sides. And I know that when I take the square root, I always have to consider the positive or the negative square root. So I'm going to have plus or minus the square root of 10 equals x minus 3. And to get x by itself, I'm going to add 3. So I'm going to add 3 to both sides, add 3 here and add 3 here. And I get 3 plus or minus the square root of 10 equals x. So that means I have two roots represented here. X equals 3 plus the square root of 10, and x equals 3 minus the square root of 10. And again, these are the two zeros. If I were to graph this, 3 plus the square root of 10, well, the square root of 10 is a little over 3, so that's somewhere around 6. And 3 minus the square root of 10 would be somewhere around negative 3. I don't have the decimal right in front of me. And then I could find the vertex and the y-intercept, and I could graph it. We could do something like that. Okay? So the two strategies we have learned so far produce our x-intercepts. And they are great when they work, but they don't always work. So we need a new formula. And this is called the quadratic formula. This is what most people remember from algebra class. They remember that they had to memorize this big long thing, and they said, what did I use it for? And what they used it for is to find the roots of quadratics. So if you write a quadratic in standard form, ax squared plus bx plus c, okay, your a value is the number in front of x squared. Your b value is the number in front of x, and your c value is your constant, the thing that's at the end. So if I'm looking at this first problem, the one that we factored in the last slide there, I'm going to say that a in this problem is 1 because there's no number in front of x squared. I can just stick a little 1 in there if I want. I can make that a 1. Okay, I'm going to say that b is negative 6, and I'm going to say that c is 8. All right, and then I'm going to use these to fill in the quadratic formula. All right, I'm going to say that my x values are going to equal the opposite of b. So the opposite of negative 6 is positive 6, plus or minus my b value squared, which is 36, minus, and I always put a parentheses right here because it's easy to mess up this math. So I'm going to put a parenthesis right there. 36 minus 4 times A times C, all over 2 times A. Oops. And I'm not going to write A. I'm going to write what A is, which is 1. And then I'm going to clean this up. So I have x equals 6 plus or minus the square root of 36 minus 4 times 1 times 8 is 32, all over 2. Okay, and then I am going to say that, well, that equals 6 plus or minus the square root of 36 minus 32. Well, that's 4 over 2. And then I get 6 plus or minus, well, the square root of 4 is just 2 over 2. So then I get 6 plus 2 is 8 over 2 is 4. 6 minus 2 is 4 divided by 2, which is 2. So this gives me two solutions, 4 and 2. And if you remember when we solved this last one, we also got 4 and 2. All right? I would argue that if you can factor, this is much shorter than all of this. All right? But if you can't factor, that's when we'd want to use this. Okay? So this gets me my 2x values, 4 and 2. Let's look at this second example we did here, this x squared minus 6x minus 1. I'm out of room, so I'm going to do it on a new slide. I have 0 equals x squared minus 6x minus 1. And I'm going to solve this using the quadratic formula now. So I'm going to say a equals 1 because there's no number listed in front of the x squared. B equals negative 6 and C equals negative 1. All right. And what I'm going to do is I'm going to fill in that quadratic formula. So you should have it written somewhere in front of you so you have it. I have it memorized. I'm going to say x is the opposite of b, which again is 6 here, plus or minus the square root of b squared minus parentheses 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. And then I'm going to clean it up. So I get x equals 6 plus or minus the square root of 36 minus 4 times 1 times negative 1, which is negative 4, all over 2. Well, now I have 6 plus or minus the square root. 36 minus a negative 4 is actually the same as, minus a negative is the same as adding. So that's 40 all over 2. And you would think we were done because 40 doesn't have a perfect square, but 40 can be simplified. Remember that 40, if I take the prime factorization, is 2 times 20, which is 2 times 10, which is 2 times 5. So there's a perfect square hiding in there, which is 2 times 2. So 40 can be simplified, the square root of 40 can be simplified to 2 on the outside for that perfect square, and my leftovers are 2 and 5. So 2 times 5 is 10 on the inside, and then all over 2. Now I have 3 numbers that are on the outside. I have this 6, this 2, and this 2. If these 3 numbers have a common factor, then you may simplify it by dividing each of these numbers by that common factor. So in this case, 6 and 2 and 2 all have a factor of 2 in them. So what I'm going to do is I'm going to simplify this to say divide each one of these numbers by a factor of 2. So this is going to be 3 plus or minus 1 square root of 10 over 1. And because I'm dividing by 1, I don't really need to write that 1, right? And I don't need to write this 1 in front of the square root of 10. So my final answer, if I really wanted to be as neat as possible, would be 3 plus or minus the square root of 10. Okay? And that's what you get when you take the quadratic formula and you simplify it all down. You'll note that this is the same answer that we got by completing the square on this slide. Now, I think this process right here is easier, but again, it won't work every time. So this quadratic formula, you can see from these examples, will get you the exact same solutions as if you factored or completed the square. So it's worth knowing this method, and we'll talk next time about problems where you can't factor or complete the square.